quick video on how to solve radical equations. So these are equations that have radicals in it, like square roots or cube roots. So I want to go through step by step on how you would solve a radical equation. Step one, you want to make sure that your radical is isolated. In other words, you want to make sure that the radical is on one side by itself.
Okay, here I have the first radical equation, and the first step is to isolate the radical. So in order to do that, I'm going to subtract the 7. This will give me the square root of x minus 1 is equal to x minus 7.
Step two, you want to raise both sides to the power of the index. Now, the power of the index is like for a square root, it would be a 2. For a cube root, it would be a 3. For a fourth root, it would be a 4. So that's what I mean by the power of the radical. Raise both.
Step 2 is to raise both sides to the power of the index. And since we have a square root, I'm going to square both sides to get rid of the radical. When I square the left-hand side, that will leave me with x minus 1. And then on the right-hand side, that's going to be x minus 7 times x minus 7. You could do the shortcut method here, but if you don't know the shortcut method, you can just write it twice and FOIL it. And what I mean by foiling is you multiply the first, the outer, the inner, the last. So when I do that, I get x squared minus 7x minus 7x plus 49. I'm going to combine my like terms, which is the 7x minus 7x, which gives me negative 14x.
Once you raise both sides to the power of the index, your radical should be gone. So now you want to solve the equation.
Now we need to solve. So in order to solve this, we notice that we have a x squared, which means that it's quadratic. So I'm going to have to push everything to one side. So I'm going to subtract the x and add the 1. And the reason I'm doing this is to get 0 on one side and standard form on the other side, where I have x squared minus 15x plus 50. Now that I have it in standard form, I can factor. So what number when you multiply, or what two numbers, when you multiply you get 50, but when you add them you get negative 15. That's negative 10 and negative 5. So this factors into x minus 10 and x minus 5. So solving this, I get x is equal to 10 and x is equal to 5.
After you've solved the equation, step 4 is to check your answer. You want to check the answer that you found in the original equation to see if it works. You want to make sure you do this step because it may not always work. If it does work, then that is your solution. If it doesn't work, then you say no solution.
Okay, the final thing that we want to do here is check our answers. We got x equals 10 and x is equal to 5. Now let's start with x equals 10. What I'm going to do is go back to the original equation and plug in x equals 10. So wherever I see x, I'll put 10, and then I'll simplify. And as you see, when I simplify the answer, I get 3 plus 7 equals 10, and that's actually a true statement. Now let's check the next answer, x equals 5. So I put 5 wherever I see x, and I go through and I simplify. And when I simplify, I end up getting 2 plus 7 is equal to 5. And we know that that's not true. So we say false. So our only real answer here is x is equal to 10. What we have here is an equation with two radicals in this. So what we're going to do is take another approach. If you have two radicals, you want to try to isolate one of the radicals. So in order to do that, I'm going to move the square root of x plus 11. I'm going to move that to the other side just to isolate the other radical. And when I do that, I get square root of 2x plus 8 on the left-hand side. And then on the right-hand side, I get negative 1 plus square root of x plus 11. Now, step 2 says to square both sides. So I'm still going to take that approach. Because we have a square root, I'm going to square both sides. On the left-hand side, the radical goes away. I get 2x plus 8. On the right-hand side, I have to write the negative 1 plus square root of x plus 11. I have to write it twice and FOIL just like I did in the previous problem. So I'm going to multiply negative 1 times the radical. Negative 1 times negative 1, sorry. Then negative 1 times the radical. Then the radical times negative 1. And then the radical times itself. So let's see what happens here. Negative 1 times negative 1 is 1. Negative 1 times a radical is negative the radical. Then the radical times negative 1 is negative the radical again. And then a radical times itself is just going to make the radical cancel out. So I get x plus 11. Now at this point, I'm going to combine as many like terms as I can on the right hand side. So the 1 plus 11 comes together. That makes 12. And then I have the x. That doesn't combine with anything, so it sits alone. And then I have negative radical and then negative radical. So think to yourself, negative 1 minus 1 is negative 2. So you're bringing two negatives together. You're summing them together basically. So you're doing negative 1 plus negative 1, which is going to give you negative 2. And then you tag the radical onto the end. So negative radical minus radical is equal to negative 2 radical. So what we're doing now is we need to isolate this other radical. The negative 2 radical x plus 11, I need to isolate this. So in order to do that, I got to move that 12 and I got to move the x to the other side. So it's like we're starting the process all over again. When I do that, I get x minus 4 is equal to negative 2 square root x plus 11. Now I square again because I have another radical I need to get rid of. So I square both sides. I do x minus 4 times x minus 4, so I have to FOIL this out, which is going to give me x squared minus 4x minus 4x again, and negative 4 times negative 4 is positive 16. On the right hand side, I have negative 2 squared, which is going to give me positive 4. And then a radical squared is just going to give you what's underneath the radical, which is x plus 11. So I distribute and get 4x plus 44. And we're finally at the point where all the radicals are gone and we need to solve the equation. This is a quadratic, so I need to work to get everything on one side. I combine the negative 4 and 4 and get negative 8. I'm going to move the 4x and I'm going to move the 44. So x squared minus 12x minus 28. And when we factor, we end up getting x minus 14 and x plus 2. So if I go through and solve, I end up getting x is equal to positive 14 and x is equal to negative 2. So just when we thought we were finished, you have to go all the way up to the top. Go to the original equation to check whether these are both true solutions. So if you go through and you try to plug in x equals 14 for all of the x's in the original equation, you're going to see that that doesn't work for your equation. I checked it in my calculator and it just does not work. So x equals 14 is not one of your solutions. Now try to plug in x equals negative 2 for all of your x values in the equation. And when you do, you will see that it does indeed work. So x equals negative 2 is your solution. Smart.
Okay guys, I hope that's helpful.